Welcome to the project demonstration of three-phase transmission line fault identification along with location. And here the faults are like line to line fault and line to ground fault. At the same time, the same details will be sent to the mobile phone through IoT application along with the location of this system, and that will be getting from this GPS module. And whenever the fault occurred, the respective phases will be isolated with help of this electromagnetic relays, and we'll get the audible alert through this buzzer board and LED indication from this LEDs, and the same status continuously monitor on this 16:2 LCD screen. So all these input and output modules are interfaced to the Arduino Uno board. From there the system will be control the input and output modules. So the inputs is directly from this three-phase transmission line presentation, and so here we are representing this line 3, line 2 and line 1, and the kilometers we are denoting 2 kilometers and 4 kilometers and 6 kilometers and 8 kilometers. So this is the ground line and the 3 transmission lines along with the ground line. So here we have interfaced these input sensors of the current measuring from these transmission lines at A0, A1 and A2 pins, as well as the output relays are interfaced directly to the Arduino Uno board at pin number 11, 12 and the 13th pin and 10th pin to the buzzer board, and 8, 9 to this ESP8266 Wi-Fi module, and GPS interface at the pin number receiver, that is the 0 pin. And these 3 LEDs interface at the A4, A5 and A3. So these are the pins for this one, and the LCD display at pin number 2 to pin number 7. So here the main power source input is 230 volts AC input, and that is parallelly distributed connected to these 3 loads through these 3 relay boards. And this one is the regulated power supply board which is used to get the 5 volts DC output from the 230 volts AC inputs. So once we provide the 5 volts DC over here, this is the breadboard. So throughout this board we are distributing the 5 volts power supply from this regulated power supply board. The 5 volts power supply is the main source voltage of our total system. So let us check with the demonstration. So before demonstration we need to on the hotspot in your phone. For that, configure the hotspot name to project 7717, and password should be 123456789, and the AP band should be 2.4 gigahertz, and this is the security. So after set these settings on the hotspot, and now we need to install the 2 applications. One is the Juice SSH. So if it is not available in the Play Store, type this in the Google and directly from the Google install that application, and Network Analyzer application. So these 2 applications we need to install. So after these 3 settings successfully done on the power supply to this kit, and once we on that, there we can see the welcome message in your LCD display, and everything is normal and no fault. So when we demonstrate the kit, if we place the kit near to the window to get the sky vision to this GPS antenna, there we get the live location values instead of 00. So we'll demonstrate at the end of the session. And here we can see one device is connected. Okay, now to get the IP address of the device, go to Network Analyzer application, options, LAN scan, do the scan. So there we get the 2 IP address. One is our mobile phone, this is one place, and another is our kit. Now copy this, then go to Juice application, right, and manage connections, add it. So here the type is telnet, then paste the IP address and port 8080. So these 3 settings to be done successfully, then tick. Now click on this, right. So you are going to continuously stream the data over here, right. So coming to the fault, so now let us make a fault over here. Okay, and now I'm correcting that to here line 2 and line 3. So line 2, line 3 at 2 kilometers, same message is on your application, right. And when it is coming to normal again, it will be off. Same for line 2, line 3 also, 3 phases, line 2, line 2, line fault, right. You can see that, right. So 3 lines. So line 2 and 40. If is there any like loose contact at this crocodile pins, then it will be fluctuate values. So you can see that values over here. Now remove this, right. So normal here, and coming to the line to ground also, right. Okay, L3 to ground at 2 kilometers. And now if we change this to line 2, so line 2 fault, L2 ground, same message here, and the indication same for right, L1 ground here, and same for here. So L3 ground at 4 kilometers, right, and next L1 ground at 4 kilometers, right, L2 ground at 6 kilometers, and next L2 ground at 8 kilometers. So if I'm touching that, if it's a loose contact, then L3 ground at 8 kilometers. Okay, and next I'm making a fault of line to line over here, right. So L2 L3 at 8 kilometers. L2 ground at 8 kilometers here, and the same thing here, right. Okay, right. So when we demonstrate that, so this crocodile pins has a contact based one, so we should be touch properly to that. If it's any loose contact over there, so there's a chances for sparks, and we'll get the values fluctuation, right. Right. Okay. Level demonstration, you should take care these crocodile pins should not fall on any one of the circuits, so please take care of that. These are the values we are going to reset. So if any malfunction occurred, this is the reset switch to restart the microcontroller to get the continuous data streaming. Now let us check with the demonstration under the sky vision, so that we are going to get exact location values. Right, so when we place the kit under the sky vision, there we can see the light blinking on the GPS. On LCD we can see the 1778 is directly our coordinate values. So there, if is any fault occur, same here we can see on that also. Okay, so if is any fault occur here, let us make some fault. So this is the fault, right. Sorry. Right. Right here, right, and in the same manner in the mobile phone we're going to get that same fault for this here. So just click on this, it will directly redirect it to the location of this fault. Okay, same like ground fault. So we done the LG fault at 4 kilometers, right. HVS technologies, and we got the same location, right. In the same manner it is sending the L3 G fault also. You can see that L3 G fault, right. Thank you.